All right, since we've taken our first test on the unit about similarity, we're going to step on and talk about other ways that you can tell if triangles are similar. By definition, two triangles are similar if the corresponding angles of one triangle are congruent to the corresponding angles of another, and corresponding sides are proportional. But there are actually three other ways you can prove triangles similar without having to use all of the sides and all of the angles. One postulate, two theorems. So we're going to take a look at those three and then have you practice identifying similar triangles and identifying the postulate or theorems that are used to state that they're similar. All right, so the first one is postulate 7.1. It's called the angle-angle similarity. Notice just two A's. Angle-angle similarity postulate. It says if two angles of one triangle are congruent, meaning they have the same measure, to two angles of another, and they're the corresponding angles of another triangle, then the triangles are similar. Now, if you keep in mind, if two angles of one triangle are congruent to two angles of another, we have had a theorem in the past that said that the third angles are also congruent. So because two angles are congruent, two pairs of angles, we automatically know the third ones are also. And what that's going to do is it's going to force those sides to be proportional. So the AA similarity postulate allows us to state that two triangles are similar without having to know everything about all the angles and all the sides. So there's one of our ways. Another, theorem 7.1, side angle side similarity. You remember we had an SAS for congruence. Well, now this is an SAS for similarity theorem. It says if two sides of one triangle are proportional to two, or the corresponding two sides of another triangle, and this is very important, their included angles are congruent. Can't be any other angle. It has to be the angle that is between those two proportional sides. If that is true, so it goes a side, then an angle, then a side. Proportional sides, congruent angles, then the two triangles are congruent. Because those two sides are proportional and they're open a certain angle, what it does is it forces the other angles, corresponding angles, to be congruent and the third side to be proportional. So we'd have to know that A and Q are congruent, and AB over QR, those pink sides, are equal to AC over QS, then the two triangles are similar. Again, these are all about similarity. And then the third reason, and it is also a theorem, is the side-side-side similarity. It says if three sides of one triangle are proportional to three sides of the other, then the triangles are similar. And again, it takes all three sides. If we know nothing about any of the angles, it takes all three sides of one to be proportional to all three sides of the other. You're going to be happy to know that we're not going to take time to prove these. If you Google it, if you want to see a proof, you could Google them and see a proof of the theorems. Right now, we're just going to practice using them and see if we can identify whether triangles are similar and what theorem or postulate. So we have an AA similarity, a side-side-side, and a side-angle side similarity postulate. All right, so I've got 4 examples here. See if I can blow it up a little bit. It says determine if the triangles are similar. If so, tell why, and that would be our theorem or postulate. And then we'll write the similarity statement and the scale factor, or in other words, the similarity ratio. Okay, 2 words for it. Some of these, you might be more comfortable taking them apart because several are going to be embedded triangles, one inside another. For example, this is one of those. We have a large triangle, and if you want to redraw it, let me just sketch it. It's not going to be real pretty, but here's M, J, N. And then there's a smaller triangle up top that's K, J, L. And we have a 3 here, we have a 2. And that whole side from M to J is the 4 plus 2 or 6 long. And the entire side from J to N is 3 plus 6 or 9 long. You don't have to draw them separately, but it might help you see it. Well, if you take a look, we don't know anything about 2 pairs of corresponding angles, so it's definitely not AA, can't use that. We do know something about 2 sets of sides, so let's check those out. This might be the SAS, because we know something about 2 pairs of sides and the angles. We do know that we have angle J is congruent to angle J, because they both share it, so there's a congruent angle. And if we look at the ratio of 2 over 6 and 3 over 9, those are the corresponding sides, both of those reduce down to 1/3. So we have 2 pairs of corresponding sides proportional. The angle between them, the included angle, is congruent, so they are similar by the SAS similarity postulate. And if we write a similarity statement, we could say that triangle MJN is similar to triangle, all right, M and K are corresponding, J and J, and N and L. And our similarity ratio is 1/3 or 1 to 3, because we found that out when we checked to see if the sides were proportional. All right, we have one under our belt. Let's take a look at another one. Again, you can take these apart. You can leave them together. I'm going to take this one apart. I have a small triangle over here on the left, and let me turn it a little bit. Notice that 2 sides are 4 long, and one side is 6, so I'm going to turn it around so it sits on that long one. Q is the angle between the 2 sides that are 4 long, and I'll put P here, and there's R. And now let me draw the other one, kind of sketch it out, sitting the same way. Each of those 2 sides are 6 and 6, and no, that's not a very pretty triangle, but it'll work. The side at the bottom is 9 long. R is at the top. And P and S. That is a really ugly triangle, isn't it? But it will work for what we need to do. All right, looks to me like we know absolutely nothing about any of the angles. So if it's going to be anything, it's not SAS or AA. It might be SSS. And we do know something about 3 pairs of angles. So let's see if, or 3 pairs of sides. Let's see if they're proportional. We have 2 sides that are 4 long and the small one, 2 sides that are 6 long. So the 4 to 6 must be the ratio of those corresponding sides. That reduces down to 2 to 3. And then that base, the long side, that's the 6 and the 9. And 3 will divide into both of those evenly. So that also reduces down to 2 to 3. So since the ratio of all the sides reduced down to 2 to 3, they are similar. So that's a yes. They are similar by the SSS similarity. That would be a theorem. The similarity statement, it is so much easier to see when the triangles are taken apart. I'm going to start over here with P and say triangle PQR is similar to triangle. P matches with P, that would work. PRS And since when I was checking to see if the sides were proportional, the similarity ratio was 2/3. We could say their similarity ratio or scale factor is 2:3. All right, 2 of them under your belt. I think the more of these you do, the easier they get. We've been dealing with similarity ratios, writing similarity statements, so it's just using the theorems as something new for us. Let's check out this next one. All right, these are already taken apart. We have a little bit of information about angles. 2 angles of each one. Probably ought to check out and see what the third angles are. So that's in the triangle on the left, that's a 52 and an 81. Let's add those up, see what they add up to be. That's 133. And so the third angle in that triangle, that's a 7. So that is a 47 degrees up there. Oh, look. Angle A is 47. That's what angle F is. That must mean angle G is 81. We know nothing about the sides, but we do know that we have congruent angles. So here's a pair of congruent angles. Here's another pair of congruent angles. So by the AA similarity, the 2 triangles are similar. And their names are ABC is similar to A matches with F, because they're 47 degrees. B is 81, so that matches with G, which is also 81. And C is 52, and H is 52. So triangle ABC is similar to triangle FGH. And we can't tell what the similarity ratio is because we don't know anything about the lengths of the sides. So that would be something that we cannot answer, interestingly enough. All right, one final one. Now, kind of take a recoup. We've had an SAS similarity, an SSS similarity, and an AA similarity. So we've had one of everything. So who knows, maybe this one won't be similar, maybe it will be. They're not turned the same direction. I'm going to make it a little bit easier for us to see, and this is not going to be one of my pretty sketches again. So not a very steady hand sometimes, but I want to get this sketched out quickly, so I'm just going to freehand it. There we go. Could be worse. All right, small triangle. T is at the top. Q is over here, and where S is, they have one right angle mark. That means the other one is also a right angle. And then on the large triangle, S is a right angle, R and P is at the top. There we go. All right, so angle T and angle P are congruent. Where the S's are, those are congruent. So we have 2 pairs of congruent angles. So by the AA similarity postulate, the 2 triangles are similar. The 2 names are triangle TSQ, and that is similar to triangle, all right, P matches with T because they're congruent. S and S are congruent, and so the other one is R, so PSR. And because, again, we do not know the lengths of the sides, we cannot calculate that similarity ratio. All right, the assignment that's going to be going with this is simply practicing identifying if triangles are similar and deciding which theorem or postulate you can use to prove that. So very much like these. You can see the assignment on Canvas. If you're in class, we'll have a paper copy. This is not something you need to wait to have the paper copy of, though. If you are not in class, just go ahead and do the one that is posted on Canvas.